Example, solve the following second order ODE using the Laplace transform. So the ordinary differential equation is this, okay? And we have another condition, initial condition, and then another initial condition. So by using Laplace transform, okay, you must use Laplace transform to solve this. So firstly, we apply the Laplace transform for each term or for both sides. So the Laplace of double second derivative plus the Laplace of the second term plus the Laplace of the third term equal to the Laplace of 0. Now look at each term. The first term is the Laplace of second derivative. So you have to apply the formula for the Laplace transform of derivative for the second order. So the Laplace of f double prime from the formula equal to s square fs minus s f0 minus f prime 0. In our case, we use y. So here we can substitute f to y. So now it becomes capital Y, and for each f replaced by y, right? So the equation becomes s square capital Ys minus s y0 minus y prime 0. Next, we want to find the Laplace of the second term, which is 3y prime. Since 3 is a constant, let's put that outside. Okay, so I want to put number 3 on the outside. So here it becomes plus 3. You have to find the Laplace of 3. You have to find 3 multiply the Laplace of y prime. So you have to use the formula for the Laplace of the f prime as well. So let's write the Laplace of the first derivative is fs minus f0. So our equation is plus 3, and we put a big bracket here to include the Laplace of the first derivative. So it is s capital Ys minus y0. So that is the Laplace for the second term. And for the third term, 2 is just a number. Again, you can bring it outside. So it is plus 2. The Laplace of y is just capital Ys. Right. Next, on the right hand side, Laplace of 0 is 0. Okay, it's a constant. Why we get 0? Because we apply the transformation of a become a over s. So if your a is 0, so the Laplace is 0 over s, which is equal to 0. So now you have a long expression on the left hand side. We have to simplify that, and let's apply the condition here. Y0 equal to 1. We can replace this as 1. This one is y0 1 as well. What else? Y prime 0 is 0, so we can replace y prime 0 to 0. So that's what we have for now. So we want to simplify and rewrite. So this becomes minus s plus 3sys minus 3. Okay, since this is 1, 3 times 1 is minus 3 plus 2ys equal 0. Now the next step is to factor ys. We want to collect all ys. So the elements inside the bracket is s square plus 3s plus 2, and we make a factor. And the remaining terms can be put on the right hand side, this one, minus s, this one, okay? So it is s plus 3 on the right hand side. Now write your ys, it is a fraction. Okay, now look at the denominator here. Can we factor? Yes, of course. We want to put in factor form, so it is s plus 1, s plus 2. Okay, next, your aim is to find yt. You need to find yt. Yt is the inverse Laplace of ys. Your ys is in this form. You cannot find the inverse Laplace of this directly. One way to make it simpler so that you can use your table of Laplace transform later is by using partial fraction. Which means s plus 3, s plus 1, s plus 2. By using partial fraction, we separate the factor like this. Okay, and then let's find a and b. So how to find a and b? We need to multiply each term like this. Then you can make the numerator equal a s plus 2 plus b s plus 1 equals s plus 3. After that, let's expand this. The right hand side remained. On the left hand side, you can collect s, you can factor that, so a plus bs. Then you just to write the remaining parts. Okay, it's now to do the comparing process. On the right you have s, on the left you have a plus b. So means that the coefficient of s here is 1. You can write a plus b equal to 1. And the other equation is 2a plus b equal to 3. Now you have a system. Okay, you have a system. You can solve this simultaneously. You can use your calculator. You will get the answer a equal to 2 and b equal to minus 1. Now your ys can be written in partial fraction form, a over s plus 1. So 2 over s plus 1 minus 1. Since b is minus 1, I put minus in the operation. So this is ys. Now it's easier to find yt by finding the Laplace inverse of each term. Okay, now look term by term. For the first term, let's put the constant of 2 outside. Now you can refer to the table of Laplace transform where you have e negative at 1 over s plus a. So for the first term, your a equal to 1, right? So means that it is e negative t. So 2e negative t minus. And the next one is 1 over s plus 2 is e negative 2t. So this is your final answer. The answer is 2 exponent minus t minus exponent minus 2t.